All right, so the exam 3 open review session is now officially open. So what we're going to start with is I had a Canvas messages question that wanted to see the different combinations of hypothesis testing and basically the different combos of one-tailed, two-tailed, independent means, dependent means, and single sample. So we're going to start with that, and if any other questions pop up, let me know, and we'll make sure that everybody gets ready to go for the upcoming exam. So first thing we're going to do is we are going to, we'll start with the 2 template questions, just so that we're absolutely sure how to handle those 2, and also because those ones are ready to go. So if you want to follow along, there are these 2 exam 3 template questions. So let me get a little bit more, let's see if I can get that a little bit smaller so we can see this. All right, so it's this question right here, and let me fire up the IU anywhere. All right, so while we're waiting for this to load up, I'll give you one little tip that you can use in the exam to sort of help you along with your decision making in terms of which test you need to do. And that has to do with a very quick way of deciding between a one-sample t-test or one of the other t-tests. And for that, you can look at simply how many sets of scores do you have. So for example, when we take a look at this first one here, when we take a look at the blah x versus blah y, there's 2 possibilities for this particular experiment. It could be an independent means t-test, where both of these subjects they're different sets of subjects. So we have 15 individuals in the blah x condition, and then we have a different, separate 15 individuals in the blah y condition. Or it could be a dependent means t-test, where we have 15 individuals that experienced the blah x condition, and then those same 15 were measured a second time on the blah y condition. So when you see these 2 sets of scores, it could be either a dependent means t-test or an independent means t-test. On the other hand, bless you, when you have only one set of scores, that by necessity is a single sample t-test, because you only have one set of scores and you're going to be comparing those scores to a hypothesized mean. So in the exam, if you come across a situation that looks like this, where you only have the one set of scores, you don't even really need to read the question. You can just simply go ahead, do your single sample t-test. You do need to find out what your hypothesized mean is, but you don't need to take too much time deciding what test you're going to do. On the other hand, when you're in this situation here, this is one where you need to read the description to know which particular test it is. So we'll start off with this one here if we're doing a two-tailed test on the alpha 0.05, and we'll start off with the dependent means t-test. So in a description of a dependent means t-test, you're basically going to be looking for language or information that the one sample, one group of subjects is measured twice. And there'll be different information in there. For example, in this case, it'll say 15 subjects ran in the blah x condition, and then the same 15 subjects ran in the blah y condition. It'll say that the experiment contained 15 subjects in total. So we know that we have 15 in total, which means that these 15 are the same as these 15. So look for language like that, especially the total number of subjects will give you a good clue. If the total number of subjects equals the subjects in each sample, then logically it has to be the same group of subjects measured twice. If, on the other hand, it said, oh, we had 30 subjects, then logically those 30 subjects got split up into 2 groups of 15. So if it was saying that there were 15 subjects in total, the subjects were measured once on the blah x group, blah x condition, once on the blah y condition. Is there a significant difference between those two conditions? Use a two-tailed test with an alpha of 0.05. That's a dependent means t-test, so we would want to set that up once we make that decision. So to set that up, we copy our blah x scores, we go over to SPSS, we paste that in to the first column there. We go down here to variable view and we put in that is blah x. If, again, something goes wrong, for example, you put a space in, SPSS will let you know. Don't panic on that. Variable name contains an illegal character. That is fine. We just correct it. So we call that one blah x. And then the blah y conditions, because they are the same subjects, they have to be placed in the same rows, which means that they need to be placed in column number 2 so that every row has 2 scores. That's the blah y condition. And then we have those two set up for this situation. So in this case, I just realized I skipped over the hypothesis test, the setting up the two null and research hypotheses. We should do that first. So let's zoom in here so we can see a little bit better. And in our question, this is another shortcut you can use. We're asked to use a two-tailed test with an alpha of 0.05. Once you know that you're looking at a two-tailed test, the hypotheses, null and research, are rather easy to do. The null hypothesis is that the two population means equal each other. And the research hypothesis is that the two population means do not equal each other. That's for any two-tailed test. So once again, once you know it's a two-tailed test, the null hypothesis is that the two equal each other. The research hypothesis is that they do not equal each other. If it's a one-tailed test, you need to look for language that indicates which direction that test is going in, and we'll get to that on the next, once we're done with these 3 examples here. So once we have the null and the research hypothesis, and we've decided what test we're going to do, and we formatted it correctly, it's time to tell SPSS what test to actually do. So we go to Analyze, we go to Compare Means, we go to, in this case, for the dependent means t-test, the paired samples t-test, and then for a two-tailed test, well actually for one-tailed or two-tailed, if you're using the p-value, it does not matter which way you put your scores in there. And that's all that we're going to be doing for the exam. It's the p-value versus the alpha level. So we pop those in, and then we can hit OK, and it runs the dependent means t-test. Yep.
How did you get there again?
We go to Analyze, Compare Means, and then it's the paired samples t-test. All right, so we have our output here. And once you get to that output, again, make sure that you check this top table here just to make sure that you entered in the data correctly. So we see here that we have 15 scores in the blah X, 15 scores in the blah Y condition. Double check with your Excel sheet and we'll see that we have 15 subjects in the blah X, 15 subjects in the blah Y conditions. So that gives us confidence that we got that correct. And then the means over here, it's very easy to just quickly go equals average if it hasn't already been calculated out for you. Just calculate out those means. We got 33.7, we got 45.87, and then go back to SPSS, and sure enough, 33.7, 45.87. We know that we've entered in our data correctly. So this is especially important in the exam situation because while you will not be under time pressure, so this exam, if you speed run through it, I could imagine everybody being done in about 20 minutes. So that gives you just under an hour to think about the tests, make those decisions. You're not under any time pressure, but you might feel like you're under a little bit of time pressure. I know exams can be, stressful situations. So mistakes happen under stressful situations. Double check, make sure that you look at this paired samples statistics up here. Right number of subjects in each condition, right mean for each condition. That gives you confidence. that you've entered it in correctly. This paired samples correlation, we're going to completely ignore that. And then the last thing we need is to take a look at this paired samples test output here and find all the information that we need to answer our question. So the first thing we need is we need the degrees of freedom for our comparison distribution. That degrees of freedom is that right there. So we got degrees of freedom is 14. So we can pop that into our degrees of freedom here. The standard error, estimated standard error, that is this right here. So notice we got standard errors up here. We want the one that's down here, this 2.86501. And in the exam, I highly recommend just pop in the entire value from SPSS. That'll keep you from making any rounding errors or anything like that. And it's just a good practice to get into. All right, for the alpha level here, this one, do not second guess yourself. It is literally the alpha level that was given to you in the question. So this does not get tampered with. This is my early Christmas gift to all of you. Alpha level is 0.05. You just put 0.05 in here for the alpha level. Sometimes students second guess themselves and think it cannot possibly be that easy. And they'll do things like divide the alpha by 2, which is a big no-no. You don't touch the alpha, just pop it in there. We need it. We need to know that you are aware of what it is. So that's why step 3 is right there. Step 4, we get the p-value. Now, because this is a two-tailed test, we can take this p-value directly from SPSS. We don't have to do anything with it. So it's 0.001. So we pop that in right there. And then finally, we have to decide whether we're going to accept or reject the null hypothesis. You'll notice that SPSS is not displaying the 1 there. Again, we can just fiddle with the decimal points, or if it's during an exam situation and you don't see the value that you put into your answer cell in there, you can call me over. I'll increase the decimals for you. But now we have our final decision. Do we accept or reject the null hypothesis? And I highly, highly, highly recommend, unless you are rock solid with this, go to the PowerPoint slides, go to the PowerPoint files, and it is repeated in multiple places. But I would highly recommend have this particular file, let me find it. You might want to have these ready so that you don't spend time like I'm doing right now trying to find them, but have these 2 slides ready to go. So decide whether to reject a null hypothesis. If the p-value is less than alpha, this is what you do. If the p-value is greater than alpha, this is what you do. So if you have those 2 slides and you'll notice that our p-value is less than our alpha, even just as again, a double check, p-value is less than alpha, we accept the research, we reject the null. So we would then reject the null hypothesis here, and we would accept the research hypothesis, and that would be the way to answer question number 1. So that would be if it was a two-tailed hypothesis test. Now let's say that it was instead, it was a one-tailed hypothesis test. And let's say that we wanted to know, not is there a significant difference between the attitudes for blah x but blah y, but we want to know if blah x is greater than blah y. Or another way to put this, based on these results, are the attitudes for blah x greater than blah y, stronger than blah y, basically bigger than blah y. So if it's a one-tailed test, you will have language in the description just like this, where it says, based on these results, is this one bigger than the other condition? Is this one greater than the other condition? Or you might have it going the other way. Is it weaker? Is it smaller? Is it less than the other condition? So make sure that you check out that information. So based on these results, are the attitudes for blah X stronger than for blah Y? And in this case, let me change that up. I won't do this to you, but all right. So based on these results, are the attitude for blah X weaker than blah Y? So I changed that up because the attitudes for blah X are actually weaker than for blah Y. And I will not be asking you if something is greater than something else and then sort of do it's a completely valid thing to do, but it is a little sneaky in an intro to statistics course where it's not in the direction, at the very least, that you expected. So when I say something like, are the results for blah X weaker than for blah Y, or the attitudes for blah X weaker than blah Y, I will make sure that blah X actually is smaller, and the question is it smaller enough? So in this case, we have that we're testing if blah X is smaller than blah Y. The research hypothesis is the easier one to do for the one-tailed test. So in this case, we want to know, are the attitudes for blah X weaker than the attitudes for blah Y? So that means, are the means for blah X less than for blah Y? So make sure that you're reading the subscripts here, because I will identify which mean goes with which population. And if it's blah X weaker than blah Y, that literally means, is the mean for blah X less than the mean for blah Y? That would be the research hypothesis. That would be what occurs if there is an effect. The complete opposite of that is greater than or equal to, and that's what your null hypothesis becomes. So in a one-tailed, always make sure that you go for your research hypothesis first. The research hypothesis is the more straightforward one to do for the one-tailed test. Now, the nice thing about the one-tailed versus two-tailed is that the rest of this barely changes. So the degrees of freedom, still the same degrees of freedom. That doesn't change in a one-tailed test. So we still read off of the table. We still have the right degrees of freedom. And for the estimated standard error, that is still the same estimated standard error. Alpha is still the same alpha. Alpha has not changed. One-tailed or two-tailed, alpha is alpha. What happens now is that our p-value, instead of being 0.001, we have to now take that, and you can do this right in the answer cell. We take that p-value and we divide it by 2. So once again, Excel is rounding that off, but you can see now that it has been cut in half. And then we go back to our decision slides here. If the p-value is less than alpha, in fact the p-value is less than alpha, what do? We accept the research hypothesis, we reject the null hypothesis, so we make sure that these reflect that particular decision. Mm-hmm.
So you're dividing the p-value in half if it's a one-tailed test?
Yes. Yes. And the reason for that, just to give you a visual of what's going on, what SPSS does is it figures out the probability. So that p-value is literally the probability that you would get a sample that extreme or more extreme, either going high or going low. So what SPSS does is it figures out where your sample mean is, right? It figures it out that your sample mean is right there on the comparison distribution. It then says, using your sample mean as a cutoff score, how big is this tail over here, and how big on the negative side would that tail be as well? Because a two-tailed test means that you're looking at how likely would it be to get a sample size that extreme, either going high or going low. That's the two-tailed. So in this case, both of these together equal that probability of 0.001, which means that this side of it is 0.0005, and this side of it is 0.0005. Right? And the two of them together give you the 0.001. So when we're doing a two-tailed, we can just read this straight up. When we're doing a one-tail, remember that we're only interested in one side, so we have to get rid of the other tail to go one-tailed, and we get rid of it mathematically by dividing by 2 and finding out how much of the probability is in this side, how much of the probability is in this tail, and lo and behold, it's that divided by 2 to get to that one-tailed probability. There's a question? All right, so any questions on the dependent means t-test? All right, so let's take a look at the independent means t-test now. So in this case, all right, so we're going to go back to a two-tailed test. All right, so in this case, we're going to be doing a independent means t-test. And in the independent means t-test, once again, we're looking for language that indicates that we had two separate samples of subjects, two groups of subjects that were treated differently. So in a description of this particular experiment, notice that we have 15 subjects in one sample. We have a different 15 subjects in another sample. At some point in the question, it will say something like there were 30 subjects in the experiment. 15 subjects were in the blah X condition, 15 subjects were in the blah Y condition, and that is your indication that we had two groups of subjects split up, each one measured once. That's an independent means t-test. So again, look for those little clues like that, especially if you see 30 subjects total, 15 in one group, 15 in the other group. That's an independent means t-test. So once we know it's an independent means t-test, we want to know, is there a significant difference between the attitudes for blah X and for blah Y? And we're using a two-tailed test with an alpha of 0.05. So once more, as soon as we know it's a two-tailed, we don't even have to look at the subscripts here. We know that the null hypothesis is going to be that the mean attitudes between the two populations equal each other. The research hypothesis is that, they do not equal each other. So we have those null and research hypothesis set up. When you're doing your exam, and I do this just in general whenever I run a new test, you don't want to, I would highly recommend against keeping your data in the data editor. So it wouldn't be too difficult to set up variable number 3 here and have that as attitudes. How many is that? 1, 2, 3. You know, have that as your attitude scores, and then have blah X over here. You know, and have that as your group section here. But when you start doing this kind of stuff where you keep moving your data or you keep adding to the data editor, what is invariably going to happen? Let me just finish up the setup here. What is invariably going to happen is when you go to analyze, compare means, this one is the independent samples t-test, you're going to have all of your variables in the variable dialog box here, and it's just going to add complexity to the question that you're trying to do, because now you have to decide which one of these is your test variable, which one of these is your grouping variable, and you just have more of a chance of doing something incorrectly and making an error. Much better would be to just, as soon as you're done with a question, highlight the cells, hit delete, highlight the column by clicking on the column header. That'll highlight the entire column. If you hit delete, it'll just get rid of the entire set of columns. And again, once you're done with the analysis, you don't need those variables anymore once you're done answering the question, and it just makes life simpler for you. So we kind of glossed over this, but just real quick, what you need to do in this situation is you take your blah X scores. So we have, these are the scores for the 15 subjects in the blah X condition. We label each of them, as being in the blah X condition. And then the blah Y scores here, the raw scores for the blah Y condition, we copy those, and those get pasted directly under the blah X scores. So those get pasted into new rows because those are new subjects, and we have to make sure that they're in their own rows. So every single subject gets their own row, and your number of rows when you're finally finished formatting your data should equal the number of subjects in your experiment. So if your experiment has 15 subjects total, you should have data in 15 rows. In this case, our experiment had 30 subjects total, 15 in one group, 15 in another group, and lo and behold, when we correctly format this, we will have 30 rows total. So make sure that that is your guiding principle. And then the last thing we need to do is we need to indicate that these are the blah X scores here. And if you know how to do this formatting in Excel, feel free to do it in Excel. Sorry, if you know how to do this formatting in SPSS, feel free to do it in SPSS. If you're more comfortable doing it in Excel, you can also do it in Excel and just, if you know how to, if you're better at, doing it in Excel, if you know the shortcuts for Excel better, feel free to do it in Excel, copy and paste that, and then you can paste it wholesale in here and have that all formatted correctly. The only thing to remember is that when you're working in your exam, you will see these boxes here. Do not go outside of the boxes. You have enough space within to do any sort of formatting that you might need to do, but do not go outside of the boxes, especially for your answers, because outside of the boxes is where the answer key will eventually go, those answer key formulas. So if you have anything that might influence your answer keys outside of the box, they might be gone when it's been graded. So just make sure that you don't fall or do that error. All right, so we have our null and our research hypothesis. We have our independent means t-test all set up. So we go to analyze, we go to compare means, we go to independent samples t-test, not summary independent samples t-test, just straight up independent samples t-test. And now we have our dialog box here, and it's a whole lot easier. We don't have to choose between multiple different test variables. We got attitude as our test variable. If you set it up correctly, just like another tip, you can't actually make the mistake of putting the wrong variable in here, because SPSS will not allow you to put the grouping variable into the test variables or the test variables into the grouping variables. So that's just another nice little check against making that error. So we put the attitude scores, our raw scores, into the test variable. We put group into the grouping variable. And then remember that you need to define your groups. So SPSS right here very nicely says, I know that you're trying to give me two groups because it's an independent means t-test, so there must be two groups. I got two question marks here because I need to know what are you calling those groups. So we hit define groups, and we put in blah X for one, and we would put in blah Y for the other. Now, just to kind of show you what might happen, let's say that your finger slips and you don't put in blah Y, you put in blah X, and then you label the second one as blah. If you hit continue, SPSS will be more than willing to accept those group names. And then if you hit OK, SPSS will look for blah X, and lo and behold, it'll say we don't have a single subject. Sorry, it'll look for blah, and it'll say we don't have a single subject that is in that group. So it will completely ignore blah Y because you didn't tell it to look for blah Y, you told it to look for blah. So that happens, and you have one of these warnings where the independent samples table is not produced, and you have this group statistics where you have a ton of you have a bunch of subjects in one group, but you have no subjects in another group. You can just go back, go to analyze, compare means, independent samples t-test. It'll all be set up there for you. click on the grouping variable, go to define groups, and see which one you misnamed. In this case, we forgot to put the Y on blah Y, and once we fix that, it will generate the test for you. So once again, make sure that you take the information that SPSS is giving you. If you have tables like this, read what they're telling you. It means that you have set up something incorrectly. All right, so now we got our t-test here. Once again, check your group statistics. We have 15 scores in the blah X condition. We got 15 scores in the blah Y condition. That's what we should have. The mean for blah X is 33.7. The mean for blah Y is 45.8. And we calculated those in Excel, and those are what we should have as well. So again, that gives us the confidence that we labeled everything correctly. We didn't make any errors in copying and pasting. So now we can go forth and analyze this independent samples t-test table. Remember that we are staying in the top row, the equal variances assumed row. And then we simply start looking for all our information. So for example, degrees of freedom here. That is the degrees of freedom right here in the top row. So we got 28 degrees of freedom. So we can pop that into our degrees of freedom. We need our estimated standard error. We find that right here. It's called standard error of the difference. Again, make sure that you're not looking up here for your standard error. Standard error is right here. So 3.49058. So we'll put that whole thing in there. 3.49058. And once again, if you're worried, your numbers are in there, and you can just increase or decrease the decimals, or you can just call me over. Alpha level has not changed. Alpha is still 0.05. Alpha is alpha. We leave alpha alone. And for this, it was a two-tail test. So once again, we go back to our SPSS output. We're looking for this significance two-tailed. Make sure that you're looking in the right position. So we have this thing that kind of looks like significance, kind of looks like that other word for p-value, which is significance. But we want this one significance two-tailed. So it's 0.002. So we pop that in 0.002, and we have 0.002 for the p-value, 0.05 for the alpha. P-value is less than alpha. What do we do when p-value is less than alpha? If the p-value is less than alpha, accept the research hypothesis, reject the null hypothesis. So we accept the research and we reject the null. And that would be the way to do that particular independent means t-test. If this was a one-tailed test, so that would be the way to do the two-tailed. If there was a one-tailed, again, you would look for, is there a significant decrease? Is there a significant decrease from blah Y to blah X? Let's say that we have that language in there. So is there a significant decrease from blah Y to blah X? That is, did the scores go down from blah Y to blah X? That is, are the scores smaller for blah X than they are for blah Y? So did the scores go down from blah Y to blah X? Was there a decrease from blah Y to blah X? Use a one-tailed test with an alpha 0.05. Basically, for the one-tailed, you need to decide which of these, if the effect occurs, if the effect is true, if there actually is an effect, which of these means should be smaller. So if they're saying, based on these results, is there a significant decrease from blah Y to blah X? That means, did it go down from blah Y to blah X? That means that the research hypothesis is that blah X is less than blah Y. So take a moment to make sure that you get that in the right direction, because it will usually be pretty straightforward. But if you see something like this, is there a significant decrease from blah Y to blah X? Ask yourself, if there's an effect, which one should be smaller? If there's a decrease from blah Y to blah X, we're looking at blah X being less than the mean for blah Y. Once you got the research hypothesis, null hypothesis, just a complete opposite. So erase everything except that greater than or equal sign, in this case, the one that's pointing in the opposite direction. And then very nicely, the degrees of freedom won't change. Standard error won't change. Alpha level does not change. Only thing that changes is your p-value. Your p-value does change. So now instead of 0.002, we take that for the two-tailed, divided by 2 for the one-tailed becomes 0.001. In this case, it hasn't made a difference in our final conclusion. We're still going to reject the null hypothesis and accept the research hypothesis. All right, so those were one-tailed and two-tailed versions of the dependent means and the independent means t-test. Any questions on those? All right, so let's round out this this look at the t-test with a look at the one sample t-test. So for the one sample t-test, you are going to first off, once again, as soon as you see just one set of scores, as soon as you see just one sample with one set of scores, that's enough, even without reading the description, that's enough to know you're dealing with a single sample t-test. It's the only one of the three where you only have one set of raw scores. So if you got just the one set of raw scores, we're dealing with we're dealing with a single sample t-test. In this case, we're going to be doing a two-tailed test with an alpha of 0.05. And the last thing we need to do is we need to have the hypothesized mean. Now for this example here, I gave you the hypothesized mean, but in the exam, you will have information in the test, in the description of the experiment that will tell you either what the hypothesized mean is or give you enough information to figure out the hypothesized mean. So for example, it might say something like, last year the scores were 30. Are this year's scores significantly different from last year's? So you need to realize that you're comparing this year's scores to last year's scores. So you need to find out, what am I comparing my scores to? So always look for that information. It's either going to be a value such as last year's scores, the general population scores, previously measured scores, the goal. The goal for this campaign was to reach this many, this particular score. Did the campaign actually, reach that score? So that type of information is one way to get the hypothesized mean. The other way is for there to be a limited quantity of something that people have two options on how to spend that limited quantity. And this is an example of that type of a single sample t-test. So you'll notice here, in all the blah, 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 blahs, right here it goes blah, there were two options, blah, 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 a total of 60 minutes. What this means is that the subjects had two options, two choices that they could make, and they had a limited quantity. They had 60 minutes to divide between those two choices. So the hypothesized mean is always the null hypothesis mean. And if there was no preference between these two options, if there was no difference between these two options, and subjects had 60 minutes in total to spend between those two options, if there's no preference, well then they'll spend 30 minutes with one and 30 minutes with the other. If there was a preference, they might spend 40 minutes with one and only 20 minutes with the other. The only way that there would be no preference is if they spend equal time. So in this case, you would see this total of 60 minutes, and you would say, all right, that's 60 minutes in total if there was no preference between the two options, and it will always be two options in this case because this is a t-test. It's when you're dealing with two levels. If there's only two options and they have a total of 60 minutes, if there's no preference, it'll be 30 minutes on one side, 30 minutes on the other side. So look for that type of language. Either this is the measure that we're going to be comparing our scores against, or this is the limited quantity of stuff that we have. We got 60 minutes, and you're going to chop that limited quantity into two. So that becomes our hypothesized mean. That 60 divided by 2 is 30. That's a hypothesized mean. That's what you're going to compare your blah X scores too. So we're doing a two-tailed test with an alpha of 0.05, so we can start off with our null and research hypothesis. For a two-tailed test, the null hypothesis is that blah X is going to equal blah Y, so blah Y is the other option. The research hypothesis is that they will not equal each other. Once we know those, we can go to SPSS. Once again, for your output, unless for some reason you're not sure about whether or not you're finished with the question, I would again highly recommend close your output. Do not save it. That will clear that output and not let you be confused with which output are you reading. Once again, highlight the entire column and delete the entire column to get rid of any data that you might have. Oh, I will just real quick mention this. Let's say that you had a column of blah Y and you wanted to reuse this column, and you were thinking to yourself, okay, I'm off to the next question. I don't need that column anymore. So I'm just going to paste right over with these scores here, and I'm just going to rename my variable, and I'm going to call it that blah X score that we're doing for this particular question. If you do that, and then you go here to analyze, compare means, one sample t-test, SPSS is going to not allow you to do this. It's going to send you an error message. It's going to say all variables in the working file is inappropriate for this dialog box. It will give you this error message. What happened here is that even though you copied and pasted numbers into your variable, you forgot that that variable used to be a whole bunch of words. And SPSS has already decided that that column is a column of words. So even if you clear out that entire column, even if you were to delete this entire column and put in nothing but numbers, SPSS has already made the decision that that is a column of words. And anything you do will not update that column of words in your data view. So the easiest thing to do is just highlight that column, delete the entire thing, take your raw scores, copy them, and then paste them right into there. And now that you've pasted raw scores into a fresh column, SPSS has decided, oh, those are numbers. And that's exactly what we need. So just an aside for that, if you find that things are not working in SPSS, it could be that your columns are just being reused. Delete the entire column, start fresh. But here we have the blah X condition here. So these are our single sample of scores. We have 15 scores in total. Notice we got 15 rows in total, so we know that we formatted that one correctly. So we're going to analyze compare means. This is the one sample t-test. So in your textbook, it's called a single sample t-test. In SPSS, it's called a one sample t-test. We click on that. Blah X is the only test variable we have. That's where your raw scores are. And then make sure that you update your test value. By far, the biggest error in running a single sample t-test is not putting in the correct test value. Your test value is your hypothesized mean. That is what you are comparing your raw scores against. So in this case, we have raw scores for how long did they spend in the blah X condition, and we're comparing that to our hypothesized mean of 30 minutes. So we have to update these so that we're comparing these scores, 42 minutes, 39 minutes, 30 minutes, 38 minutes, we're comparing them to 30 minutes because we want to know, did they spend longer than 30 minutes in this condition, i.e., did they have a preference for this particular condition? The default setting is 0. If you don't change it, all that you're testing is, did they spend time in this room? Not did they spend more time, not did they prefer this particular room, just were they ever in this room? And that's not what we're asking. We're asking if they preferred this room, that is, we're asking, did they spend different than 30 minutes in this room? So make sure that you update that test value to 30. And then once we're done that, you can hit OK, and it runs our one sample t-test. Once you're interpreting the one sample t-test, check that top table. We got 15 scores. SPSS is letting us know that they analyzed 15 scores. We go back here, we see that we have 15 scores. The mean here is not calculated, but real quick, use those first half of the semester skills. Just calculate an average for your BLA X scores. We see that we have an average of 33.37. We go back here, sorry, 33.73. We go back here and see that that is the mean that we have in SPSS as well, giving us confidence that we got those two correct. All right, so we need to find our, degrees of freedom. So we go back to the table here, and the degrees of freedom is right down here, that DF. So we got 14 degrees of freedom. So we pop that in. We need our estimated standard error. In this case, the estimated standard error is up here in the descriptive statistics table. So again, in the dependent means t-test and the independent means t-test, it's in that bottom table. In the single sample t-test, it's in the top table. Make sure that you have notes somewhere about where to find each of these pieces of information, because again, our job as psychologists is not to crunch the numbers. That's what we got SPSS for, but it definitely is to be able to interpret those numbers, and part of interpreting those numbers is knowing where to find them. So we have our estimated standard error here of 1.78477. So we'll pop that all in there, 1.78477. Once again, Excel has rounded that off display-wise, but the number is still in there. Alpha level is alpha. Don't change alpha. For this question, it was 0.05, and that is in that last sentence there. You need to have that alpha given to you. Use a two-tailed test with an alpha of 0.05. And then finally, we find our p-value here. So the p-value is this significance two-tailed. We're doing a two-tailed test, so we can read this directly off of the one sample statistics here. So we got a two-tailed of 0.055. So we put that in 0.055. Whoops. Darn you, touchscreen. We put that in 0.055. All right. Make sure that you are comparing your p-value to your alpha, not your rounded p-value, your actual p-value. So if it doesn't display the full amount, make sure that you are displaying the entire p-value that SPSS is given to you, because in this case we have a p-value that is greater than our alpha. 0.055 is greater than 0.05. So we go back to our decision slides, and notice that this decision slide works for all three tests. You don't have to find the specific ones that were for the one sample or dependent means test. They work for all of the tests. So if your p-value is less than your alpha, no, it's not. If your p-value is greater than your alpha, yes, it is. We accept the null hypothesis and we reject the research hypothesis. So in this case, we accept the null hypothesis and we reject the research hypothesis. So that's for the two-tailed test. If we were doing a one-tailed test, and we were asking, based on these results, is there a preference for BLA X? So based on these results, is there a preference for BLA X? We're going to use a one-tailed with an alpha of 0.05. So in this case, we want to know, is there a preference for BLA X? Does BLA X, do the subjects spend more time in the BLA X condition than for the BLA Y condition? 60 minutes total. Two conditions is what we have. Once again, the hypothesized mean is 30. So in this case, we're asking if they spend longer in the BLA X condition. So is the time in the BLA X condition greater than blah y? Is there a preference for the blah x condition, meaning they spend more time there? The null hypothesis is a complete opposite. If you lose your symbols, call me over. Otherwise, the places you can go to get it, if you go to insert on your Excel sheet, you should see this little symbol dialog choice up here. And if you click on that, chances are that the greater than or equal will be somewhere here. In this case, we got it right at the tail end. If not, you'll have to find it up here in these. So once you find it, you can just double click on it. That'll insert it, and there you have it. In the exam situation, I don't expect you to know how to do that in Excel, so just call me over and just tell me what you want, and I will be more than happy to insert that symbol in there for you. All right, so this would be for the one-tailed test. We have degrees of freedom. That has not changed. We have our estimated standard error. That has not changed. We have our alpha. That never changes. Do not mess with alpha. Read that directly from the question. So you might have an alpha level of 0.01. You might have an alpha level of 0.05, but you do not mess with that. And don't second guess yourself. That's my early Christmas gift. But now, since we're doing a one-tail test, remember that this is the significance for two tails. That's too many tails. We want only one. So we take that number and we divide it by 2. So again, we can do that right into the answer cells. So we take that number, we divide it by 2, and lo and behold, now we have a p-value that is less than our alpha. And if we have a p-value that is less than our alpha, we don't accept the null and reject the research. If p-value is less than alpha, we accept the research hypothesis and we reject the null hypothesis. So in this case, we need to change that up, reject that null hypothesis, and now accept the research hypothesis. And that is the entire gamut of hypothesis tests that you can have. You can have single sample, independent means, dependent means, and each of those can be one-tailed or two-tailed. Yep. All right, so that was what was asked to be seen in the Canvas messages that I received. So at this point, if there's any other questions or other things that people want to see, let me know. And I will go through them so that we can get set up and ready to go, and everybody can be prepared for exam number 3.